to effectively be able to effectively shoot a challenge like a solar solution, it means that you have to be an expert in that field or industry to be able to say a system is faulty. A client calls you, and um, you have to actually listen to the storyline of the client to be able to say, okay, this is where the problem is coming from. The client can call you and say, okay, the roof is leaking. The roof is leaking means that you have to try and limit your search instead of trying to troubleshoot the whole system. As an expert, you are likely going to be thinking, okay, most likely we are going to be troubleshooting the roof, the solar aspects of the solution. And sometimes the client can call you, the roof is shocking. It means probably there's a solar leakage. Sometimes the client can call you and say, okay, my battery does not have good backup time like it used to. So most likely you'll be thinking most likely the battery is becoming weak. Sometimes the client can call you and say, okay, my inverter is shutting down or is showing an error code. It means that most likely you will localize your search or troubleshooting to the inverter and be able to say, okay, this is where the problem is coming from. So basically today, those are the various aspects which we are going to be dealing with today. So I've give an introduction on how the topic is going to be, going to be doing with, troubleshooting in terms of solar panels, of inverters, in terms of batteries, in terms of charge controllers, in terms of all. Welcome everyone to this expose. I'm a project engineer in Genex Technologies, and I also have my facilitator here, Nyakule Olarikoya, who is our team lead, the team lead for the project and technical department in Genex Technologies. So, okay, so we're going to be talking about Genex Technologies. So, Genex Technologies is actually a leading solar company in Nigeria. So, presently, we're into sales and distribution of solar products. We're also into the installation of residential, commercial, and industrial solar solutions. They will also have a Genex Solar Academy where we actually bring out, we actually reform people we actually reform people into renowned installers of solar solutions. I'll be to Enyakule Olarikoya. He'll be taking us through this topic. Over to you, sir.
Okay, thank you. Sorry for that short break. We are going to go straight to the point. Going through the agenda, number one on the list is talking about PV system key components. Number two, PV array troubleshooting. Number three, battery troubleshooting. Number four, charge controllers issue. Number five, inverters troubleshooting, followed by wiring and protection faults, then troubleshooting toolkits. PV system components. We have solar panel. When we talk about PV system components, it's not just one or two. All components that make up the system to function as a solar system. That's what we are talking about now. Now, solar panels, which convert sunlight to DC electricity via photovoltaic cells. That we must have seen solar panels, how they look alike. We have different versions, different types, different size, different capacities, different colors, and different power rating. So all what they do is once exposed to sunlight, they convert the energy in it to electricity. Then we talk about hybrid inverter. Hybrid inverter is that comprises of all inputs and manages them well. It takes in the solar, takes in battery, takes in your load, takes in grid. Some even have generator input separately. All these are the inputs and gives an output. Now we have hybrid inverters that have two outputs, having smart outputs, and so it converts the DC power to usable AC electricity. All these that were mentioned now, because it will convert from the DC solar, send it to your load. It converts from the solar, send it to the battery to charge. So is the general manager, as I always call, because whatever you are connecting to it is the one that will manage them properly. Then we now talk about the storage, which is the battery. Energy storage for off-grid or backup power. That's the battery, that's the tank, that's where the energy is stored during the day or even during the night when you are using grid or generator to charge. Your battery is stored. If you don't have storage, then you are running on solar, which is once the sun goes out, then the system shuts down. But if you have storage, then you'll be able to get power in the nights when there is no sun. Then protections and monitoring. This has to do with fuses, circuit breakers, surge protectors, AC, CD, DC, disconnect. Those are the physical protections that you see that are additional protections for the inverter. It's not that the inverter does not have protections inside, but you still need all these to make sure that no failure is recorded. Then real-time data logging of production and the performance of the system. That's where the monitoring comes in. You'll be able to see on your phone what's going on anywhere in the world where there is internet. If your system is connected to internet, you'll be able to see it. Some have Bluetooth, meaning that if you are within a range in the building, then you'll be able to still see it on your phone. But the best one is the one that is connected to the internet. So you can monitor and you can carry out some control. Then talking about PV array troubleshooting, you can see common array problems: low power output or zero production. That's when it's not generating anything. It's not that the solar panels are not exposed, but you are not getting what you are expecting to get, like the voltage, the power from the solar, then it is a problem. Then hotspots. Hotspots are those dark points or whites. They can come in any colors, but they are patches on the solar panels that indicate damage, because they tend to rise in temperature during usage. And when that happens, they can lead to anything. It can rise up to a temperature level that can cause fire. And they are mostly caused by depth, coverage, shade, because of a kind of imbalance in the cell's performance. Then it can result to that. So shading from new vegetation or structures, this is part of what can cause trouble. Because if you put your panels and then a tree is now spreading hand to cast shadow on it, then it will cause the kind of imbalance that we are talking about the hotspot now. Then it can lead to poor generation, poor performance of the system. Probably during your installation, then the tree was not there or the arm was not spread to cast shadow. But at this moment now, your customer will complain that, oh, I'm not getting what I expect. So that could be part of it. Then lose, damaged, or poorly crimped MC4 connectors. Yeah, it is important to use to be professional in whatever we are doing. There are tools for every aspect, everything, everything. And as technology is getting advanced, you get more tools that makes life easier. So connecting cable to solar panel and to inverter, you have special tools for them, which is called crimpers, cable crimpers. So if you do it properly, there won't be loss of current, there won't be rise in temperature, if you choose the right cable. So there won't be any faults. Then let's look at the diagnostic action. Conduct thorough visual inspection of module cracks. This is physical. If you get to the roof, you can see where the panels are, where cracks are on the panel. And then if you have that, it can lead to the hotspots that we mentioned, and then it will lead to poor performance of the solar panel. So you can see cracked cables, that could lead to leakage at the end of the day. So then you correct them, and then the system continue to perform well. But the most important thing is to get a good quality of all these things, so that you also get a quality rest of mind. Measure open circuit voltage, which is VOC, and short circuit current of the solar panel. We are talking about solar panel here now. If you are not getting voltage, is either there is a disconnect. So, but if it's not disconnected, measure the open circuit voltage and reference it to what it should be. If it's supposed to be 20 volts and you are seeing 10 volts, you know that something is wrong. In the afternoon, when it's supposed to be giving you not less than 10 amps and you are getting 1 amp, even when you get the voltage, then there's a problem. So those two measurements as part of the diagnostic actions will tell you something, and they will direct you to where to go. Because if you are getting low currents, it could be a disconnect or a partial contact or a breaking out terminals like MC4 connectors or there, or a cable has cut and is partially touching or is touching another place. So anything could happen to during the course of troubleshooting, you'll be able to resolve them. Confirm accurate string configuration and cable continuity, just like I mentioned. If the cable is not continuous, you can't get anything at the output. So make sure the string configuration is proper, not when two panels are connected in series, and then you now have 3 panels connected in series. Both strings are parallel together, and there's a conflict. So all this, they ensure a proper installation, which is very important. So battery troubleshooting. Typical battery problems. Battery not charging. That's one of the problems. If battery is not charging, then it's either the charge controller is not performing well. But let me first of all just read them out. Battery not charging, fast discharging rates, overheating and overcharging, cell imbalances, BMS alarm, and sulfation in lead acid batteries. Now, if battery is not charging, it could be from the charge controller, or it could be from the source. Is it that it's not charging from utility, or it's not charging from solar? For an hybrid system, it will actually be connected to grid and it's connected to solar. So it may not be charging on one part and be charging on the other part. So troubleshoot accordingly. So the fast discharging rates mean that there's increased load or cable partial contacts or something, battery cable or breaker will have problem. Then it will look like it's discharging really, and then it will tell you low battery in most cases. So meanwhile, your battery may not be low. But if the battery is fast discharging really, then something is wrong. It's either it's not properly charged and then it's now discharging, or you have too much load on it. So that's that. Then overheating or overcharging. Well, when battery is overheating, then it's a problem. It's a serious problem. Battery is not supposed to heat up. It can warm up for some type of batteries when you use. When you are charging batteries, definitely they tend to rise in temperature. That's why for some charger, they are equipped with fan. That's why your environment for the storage should be kept cool, not putting batteries in a place that is hot, like exposing them to sunlight direct or keeping them in a room that is not well ventilated. Then when they are now working, they rise in temperature. But if they rise in temperature abnormally, you have done installation and they are working, and then this is happening, then it could be that the charger is bad. Maybe it's trying to force charge the battery, giving it more than the expected charge current, or overloading from the output. Then because if battery is overloaded, you are taking current that is higher than normal, then it will rise in temperature too. So those are the things. Or the terminals are not well connected. Then, good conductor of electricity is a good conductor of heat as well. If the terminal begins to rise in temperature because of poor or partial contact at the terminal, then it goes into the battery. The battery will rise in temperature. So you need to watch out for that. Cell imbalances. That's why at some point it's good to put battery balancers on batteries that are not equipped with a technique to make sure that when they are connected in series, they are balanced out during usage and during charging. That's well taken care of in lithium batteries, where they have the BMS, which is battery management system, which works or function as battery balancers, monitors the terminal voltage, monitors every condition in the battery. So then BMS alarms could come up by when overload occurs. Maybe the battery is overloaded because it's a sensitive and intelligent battery. We're not talking of lead acid battery now. It's lithium batteries that have BMS. So when they see shock, like overcurrent, over voltage, under voltage, they go to alarm mode to protect themselves. So it's just a way to protect the battery so that they don't get damaged. That's why I said they are intelligent. So you may not know what's going on, but you see the result that, oh, the system is shut down. What caused it? It could be alarms showing on the indication or on the battery. So you take care of that by, once it's resolved, then the system comes up. Sulfation in lead acid, could mean that the charge controller is not charging well. The battery usage, poor usage of such battery could lead to sulfation. And when it's increasing, if you are supposed to charge the battery immediately after use, you leave them for 2-3 days. They will get adapted to that condition of not having charge in them. So by the time you want to charge them, they will want to refuse. So they can tell you fully charged within a short space of time, and then when they are not really fully charged, all these conditions, when it persists, the battery will get damaged. Right? So they will no longer accept charge, and then you won't be able to use them. Now let's quickly look at additional diagnostics. You measured the voltage and internal resistance of the battery. That's part of the steps you need to take if you are having problems with battery and you want to really know what's going on. This part of step, you take your battery analyzer, analyze the battery. Of course, you reference it to the data sheet, the specification of the battery. The internal resistance of the battery will have been given by the manufacturer. So if they say internal resistance of such battery is probably 4 milli ohms, and then when you connect your analyzer to it, it's telling you 100 milliohms. So you can see it's definitely out of range. The battery has issue. So that indicates that the battery is bad. If you have such, if it's slightly beyond the standard value given as part of the specification, then you know that there's a problem. The performance will not be okay again, and that's the reason you were there to diagnose. So you record all this, then verify the state of charge. Does it really get fully charged? What's the terminal voltage at that time? So you get all that. Validate the BMS communication between battery and inverter. Are they really communicating, or the communication process has been disconnected? Is it that the cable has pulled out, or the inverter settings has changed, or probably somebody has tampered with it and then the battery no longer communicates? Then it's a problem. So conduct audits, tighten terminals, and lose connection. Charge controllers issue. Common issues include no charging, controller overheating, and auto-derating behavior, wrong setting, communication / BMS integration issues. Now, no charging. That indicates that you are not getting power from the charge controller. So it's not giving power into the battery or your load. We are talking of charging here. That means it's not delivering energy into your battery. So what could cause it from a charge controller? Your charge controller could be the inverter or the hybrid system, because it's equipped with the charge controller internally. So if it's not charging, then you check from the solar panels. Is it the breaker? Is it that the breaker is stripped off, or there's a disconnect? Check voltage. If you cannot get voltage from the solar panels, that means there's a problem out, not with the charge controller now. But if you get all those ones and the charge controller is not charging, then check for the setup or the parameter settings. If it's wrongly programmed, then it will not. It may not charge, may stop charging, or it's trying to overcharge, then it disconnect or something. So by the time all these are checked and you put them back to order, the system continues to function well. Controller overheating. That means maybe you are using a charge controller that is lower in capacity to the capacity of the battery, or the battery has issues, or now this is either overheating or auto-derating. Now, look at this. Auto-derating means the charge controller keeps adjusting itself when there's a response from the battery. The response will mean that there's a load that just comes onto the battery and that presses it down. The charge controller will want to increase its charging. If it's external charge controller, probably before that time, he's saying a battery full, and then it's not giving anything. But once load comes to it, it will start charging. But if you are charging a lithium battery that's equipped with BMS, and then it's trying to be overcharged, then it will cut off. When that happens, the over-derating behavior comes in, because the charge controller will see that there's a cutoff. It will want to adjust itself to, first of all, wait, disconnect. All that process can make the system not to charge at all. Why is going up and down, trying to monitor, is the battery connected, is this that? And for some controller, external controller, it will just get damaged. This over-derating now can be happening this way because it's an hybrid system. But if it's external charge controller that sees that the battery has been disconnected, the charge controller is going to get damaged. So it's important to make sure that a proper settings is achieved. Then wrong settings, like I mentioned, so that if you put wrong settings there, it will lead to all this. The battery may not charge at the end of the day. So communication, BMS, integration issues. So if there is issue with the system, the communication channel of the battery, then it may be affecting the charging process. So once it's corrected, everything will get normalized. Then troubleshooting steps that you need to follow: measure direct input voltage, PV voltage array. To see, do you have voltage there? So measure terminal battery voltage, see what level is it that is over the side that the charge controller cannot even recognize it to continue, or is being kept over some time and then self-discharging has come in to cause this trouble. Then confirm parameter settings. You go through the settings again, reset, adjust them if necessary. Check BMS communication, and make sure that it's properly connected. Then inverter troubleshooting. Frequent inverter faults includes inverter failing to power up. That may come from maybe battery is over discharged, and then inverter will see that, oh, if I power up, you over discharge this battery further. There are inverters that are equipped with that setup. So cold start becomes issue. It will not come up until when you first of all charge battery. And some of them may not be able to wake up the battery. It's not every inverter that has a wake up function. If it doesn't have wake up function, you need to externally boost such battery to make sure that it comes to a level where the inverter can recognize and then start to function. So overcurrent and overload, that can come from load or overcharging, because two ways: you take current from battery and you give current back to the battery. So if inverter is having problem of overcurrent, it may be coming from load. So when you have too much load on the inverter than expected, then it could be shutting down. So that's the thing. Then synchronizing phase loss could cause issue if if it's three-phase inverter and then one phase is lost, then it will shut down. It will not accept it, because a three-phase synchronous system must function under a standard condition of that three-phase system. So if not, if one phase is too low or too high, or is lost, or phase sequence is changed, is not correct, then the inverter will stop. So it doesn't mean that the inverter is bad. That way you need to check and correct them. Error or warning codes. Then you check for error or warning codes, interpret them properly, and use them to diagnose. So it could be O5, and then inverter stops. You check what is O5. For some inverter, O5 is all about fan. So maybe something is blocking the fan. Well, just go through the fault code first. It will streamline your troubleshooting process. Diagnostic checks, error code review, input and output measurements. You check the output voltage, check output, the load connected to it, then test individual breakers. At times, if breakers are not are failing, maybe there could be partial contacts in the breaker, or it will connect at some point and then it will fail at some point, becomes intermittent. You'll be going up and down. But the breaker is working. I switch it on and there is power, but the breaker is bad. So use load to test and test properly to diagnose that, oh, this breaker is actually bad. Then you replace with the good quality that will not be giving such headache. Load analysis. Check the load. Is it that the load is too much, or there are some loads that comes up that demand for startup high energy, just check, analyze the load and see that they are within the correct function of the inverter, that the inverter can really manage. Then, if everything is normal, the system works properly. Wiring and the protection faults. This is very important as well. Critical fault spot, loose terminals. This has to do with your how you handle terminals professionally. Because if you don't tighten them properly, then they will fail. Hacking will set in. And when terminals are hacking, they lead to breaker burning, cable can start burning, it will lead to fire halfway. All these, they are interconnected together because the system is just a full connection of different components working together to make that system. So if one is having issues, it's headache to the system and to the installer, eventually to the clients. So cable overheating. This comes when partial contacts or at the terminal of connection, or when cables are undersized. Maybe there is now overload on the cable, or the cable are originally undersized. If not, if the cable is within the normal standard of current capability, then there's no reason for it to heat up, unless if it's a mixture of a kind of alloy that makes it a poor quality. If not, then it works properly. Fuse and breakers, trips, then it's overload that can quickly trip breaker. Then this partial contact that we are talking about too, when the breaker rises in temperature due to partial contact, then it trips. It won't even get to the rated current before it trips up. Then the such breaker will eventually burn out. So earthing and SPD failures. Yeah. If earthing is failed, then you are likely to receive shock. There could be a complaint from the client of shock from the system. And then the system is open to damage because earthing protects the devices, protects the clients, protects, everything around it about the system. So you now have SPD in the system, surge protector device. Because earthing has failed, those surge protectors devices, they will just be there because they work with the earthing. They have earthing terminal, and then earthing has failed. They will just be there. So it's important to check all these protectors to make sure that they are in good condition. Inspection methods, continuity testing. This is where you test cables, test breakers, you switch it on, you check at the other end. Is it continuous? Is it continuous from the source to the inverter? If it's the inverter, you have to all wiring, just see between the 2 points and the components that are in between, or are those components in between the 2 points working well? Is there a connection between the 2 ends of the cable? So we check all that. That's continuity. That's, bypass switches. You do this continuity test on it, all breakers, fuses, and all that. Insulation resistance, check damaged, degraded, or short-circuited conductors. Yes, conductors can get connected together along when there is overheating caused by a short circuit, that caused by overload or reverse polarity from the installation. If you reverse polarity, reverse the solar system, for instance, now you reverse the polarity of solar array, and then you connect to some inverters you shut it down, and then the highest current will begin to flow in the cable. If you have packed everything and you don't know, and my inverter is not seeing solar, is not seeing solar. Meanwhile, you have committed blunder, and then the cable is eating. If the cable is not well sized, then it can lead to fire at the end of the day. It can lead to short circuit. It can lead to the destruction of the cable eventually, if the inverter did not even go bad at the end of the day. So it's important to choose the right cable. and make sure proper connections are made. If cables are degraded, if they are exposed, for instance, using cables that are not ultraviolet friendly, and the cables are, when they are exposed to weather conditions, sun and rain, they tend to crack. The insulation will crack off, and then the conductor inside can be exposed. Then that's where you hear your client will call you that the roof is shocking. This one, anything can happen. Such breakdown on the cable, then the best solution is to replace those cables with the appropriate standard and good quality. So there are UV cables out there that can withstand, that can be exposed, but then it's not so good to expose cable like that on the roof. Check earthing and grounding resistance. There are ways you can test to confirm that your earthing is good. You can do load test. By the time you put small load on the earthing, if it's failed, you won't even see the load will not come up. So there are ways to use capacitor to test, to make sure you still load test. You use capacitor to load the earthing. Then you can now use your meter. If you know how to use it properly, you must know how to use those instruments well. If not, if you don't know how to use instruments well, then you won't even understand whether it's bad or good, or when it's becoming bad, when it's changing. So it's important. Grounding is very, very important. And then if the resistance is very high, then or it's open, then there's a problem. So troubleshooting toolkits, digital multimeter and the clamp meter is an essential tool. I don't believe anybody will be in this industry without having this. Then, in addition to other instruments. So, to measure voltage, current, resistance, and check continuity, you need these instruments. Clamp meter is used for non-contact current measurements. That's when you separate the cables. If they are permanently attached, you need to be able to separate them. Clamp one side of it. If it's positive and negative, you clamp one. If it's live and neutral, you clamp live. And then it will show you without cutting cable, without peeling insulation or any physical contact direct to the conductor. So it will give you your results. You can measure from 0 point something milliohms to the highest as high as 1,000 ham. So depending on the capacity of the instrument you have. So insulation meter, this helps to test insulation resistance, detect grounding faults. So it's important to know that the cables that we use have rating for insulation. So if you apply voltage that is beyond the insulation, then the insulation will become conductor. It will conduct. At that, for instance, if insulation rating of a cable is just maybe 170 volts, and you now connect it to 1,000, then you have already caused trouble. 1,000 volts. So all the cables you are putting together under that condition, there will be leakage. A lot of things will happen. The insulation is already broken down. So there will be leakage to other part of the material around that place. And then if you touch it, you are likely to receive shock. You think you are touching insulation. So it's important. And it's very dangerous to the appliance, as it's dangerous to life of human being. So battery analyzer is one other essential instrument that gives you rest of mind when you want to troubleshoot battery. It can be complex if you don't have this instrument, because you won't be able to test properly. You will need to put load and you'll be disturbing your clients. Please help me put on your AC. I want to run it. Okay, the load has not reached. Okay, put on your cooker. You don't need all that. If you have your analyzer, it will just analyze the battery for you and then tell you, oh, from the specification given by the manufacturer, you have seen that, this battery has issue. That's end of story. Then you now know what to do. Whether you need to retrieve it, send it back to the supplier, or so that at least we are seeing what is happening to the battery. Thank you very much. Question and answer section.
Thank you, Engineer Kuli. Thank you for taking us through that awesome section. I know we have learned so much, and I also know that we have so much questions to ask. So we have opened up the. You can also put your questions, type your questions on the Zoom app. If you have questions to ask, you indicate by a raise of hand. Will grant you access. You'll be able to ask your questions audibly. So who is going first? Okay, so we have Mr. Chris Chukujeku. We would like you to ask your question. Okay. Okay, Mr. Chris, can you unmute yourself? Hello, Mr. Chris. Okay, we'll go over to the next person. I can see Pamela here. You can go over, you can unmute yourself. You can go on with your question while we wait for Mr. Chris.
All right, good morning. Please, we'll have to manage my this minute train, so the environment might be a little bit noisy. All right, can you hear me? Can you hear me, sir?
We can hear you.
All right, okay. I my name is Terry. My business name is Familia. All right, I asked a question some time ago on the Gen X 8. I'm actually on the Gen X 8 stream. Yes, I asked a question about the SBC battery, the DMS not communicating properly with the 6 kVA inverter, the Aspat VM3. Yeah, and I have tried everything possible. I tried everything from the manual, from the instruction that was given to me from Genex. I made sure I crimped the cable, the pin on pin 3 and pin 5 because of so that for communication and all that. And still, I noticed that the inverter is not communicating properly with the battery. So in such situation, because at the point in time, when I set it, I noticed that the battery symbol is blinking. You understand? And sometimes I'll just do a manual setting and I leave. But I keep noticing the client keeps calling me back to say that the thing is not charging properly. And when I get to the to the premise, I would notice that the charging current has changed. I've noticed that twice now. At the charging current, at the last time I went there, the charging current even changed to 10. You understand? No longer it was taking as in so much, and you understand it wasn't charging. But initially, when I did the installation, actually it was an upgrade. It was an upgrade. The client had the Aspat inverter, but we were using tubular. You understand? The first installation we did was tubular, so we upgraded to lithium battery, and I decided to go for the SBC because so many other companies said that their batteries don't communicate with Gen X inverters. So please, I want to know in such situation, what do we do? What do we do to ensure that we don't run into trouble and we don't also run into the situation of going back and forth? You understand? Because when you go back and forth to the customer premise at all times, it seems as if you don't know what you are doing. You understand? Whereas
Yes.
in actual sense, you actually know what you're doing. All right, thank you. That's my question.
Hello. Thank you very much.
Hello. Hello.
Thank you very much.
I can hear you. I can hear you.
Hello, Chris.
Okay.
I want to. Hello.
Hmm.
I want to thank organizers for this expository workshop. My question is, if there is improper. Hello.
Okay. Thank you very much.
Hello.
Let's address.
Hello.
Thank you for bringing up the issue here. It's going to be properly addressed. We don't have problems with that. Probably the communication gap or communication error somewhere. There was a time we had something close to that, and then we resolved it across board for the people, our clients or the installers, our customers that raised concern on that, and then it was properly resolved. So that will be tackled. Things that could cause that is maybe the protocol is not the correct one. If that is it, it may be communicating. You see it blinking as if it's communicating, but it may be giving you error. It is not pure. So all that will be addressed. We'll link up with us so that we can make further investigation and then give you the best solution on that. I don't see that as a serious problem, but we need to, first of all, engage you and then see how we can get it resolved. Thank you very much.
Okay, thank you, Engineer Kule.
Hello.
So,
Okay. Okay.
go,
Hello.
Mr. Chris.
go.
Yeah. Yes. My question is.
Ask your question now.
My question is, if there is improper earthing and grounding, or if it fails, whose duty is to fix it? Is it the client or the engineer? Hello, are you with me?
Can you reiterate?
Hello? It's a network. Hello? Hello?
Yeah, we can hear you.
Hello, Mr. Chris, can you start again? Yeah, start again.
If there is improper or failed earthing and grounding, whose duty is to fix it? Is it the client or the engineer?
It is the client that will pay for it, but it now depends on how you want to handle it. You want to leave the client to handle it with his electrician so that you supervise whatever they are doing, or you want to handle it yourself. If you want to handle it yourself, you already know what you want to do. But the financial part of it, because you want to work, it's not going to be free. You tell him, oh, this thing is broken down, it has to be done, this is the cost. Or please get in touch with your electrician, let your electrician do it like this, do it like this, do it like this, don't connect. We need to test if it's proper, if it's working, if it's okay, then we now connect. So that's the thing. So those are the two ways you can handle that.
Okay, thank you.
Okay, thank you, Engineer Kule, for that.
Thank you.
Okay, so the next person, Netcraft. Netcraft, can we hear your question?
Okay.
Yeah, go on.
Good morning. Can you hear me?
Yes, we can.
Okay. My question is still related to this lithium battery communication. I've been working with blue carbon lithium batteries and Sorotech 11 kVA, the VM4. I've been trying to communicate them, and most of it has not been working. It will tell you normally if you check the lithium battery sign on the inverter, it means it's communicating. But when I check, the voltage displayed on the inverter on the battery is different, and even the state of charge is also different, which means the communication is not complete. So if we have any experience on what to do to get this resolved, because what I now do is I've now resolved to use find to charge the batteries, and for some of them it has been giving issue after some time, either the BMS will get damaged or something. So that's my question.
Okay, thank you. Now, when it comes to issues of lithium batteries and the communication with inverters, there must be agreements, a proper agreements. It's always stated in the manuals of this equipment that, oh, this is the protocol, this is the point, this is the pin out for communication. So then the manufacturers must agree that, oh, my inverter can communicate with so brand of battery. It will be listed. So if we don't have all this in place and we just want to establish communication, then it may be a problem. Then if we have them in place, then it's not properly done. Probably we are not following up with the communication pin out for the cable. There are some cables that are customized, some are standard. We need to know all these. Okay, which one is the pin on the inverter that's supposed to go to which particular pin on the battery for proper communication? That needs to be put in place. Then which name will be used? Which name will be used? I think the protocol name now. For some, it could be Pylon Tech. For some, it could be even when the inverter is not, when the battery is not Pylon Tech, because Pylon Tech is like the general type of communication that is generally acceptable. But for some reasons, for some inverters, even that pylon tech will not be acceptable. It's not that it won't work. You see it working, but the communication will not be pure. So you may be seeing 10% on the battery, and on the inverter, it can be telling you 200%. So all that is still boils out to communication. It has to be thoroughly done. So this one now, we will take note of this case. Please get across after the program, then so that we can.
Thank you very much, Ejiakule. So while we wait for other people to ask questions, so we have some questions that have been written out on the Zoom platform, which we'll read and we'll also answer. So the first one is, so where is the best place to connect your SPD? Is it at the input side of the breaker, which is the PV side, or the output inverter side? And also, what is your take on breaker fire extinguishers?
Okay, thank you very much. The position of connection of SPD, as a matter of standard, is directly at the input of your equipment, if it's inverter or appliance whatsoever, because SPD is not just for inverter. But in this case now, we are making inverter as reference. Then directly at the input terminal of the inverter, which means the power coming from the source has passed through the breaker before getting to the SPD. And where it's getting to the SPD is at the same point where it's getting to the inverter. So that if there's a short circuit due to the performance or the work on the protection action of the SPD, and it happens to shut down, then the circuit breaker is there to open the circuit to avoid leading to fire or a kind of short circuit that will now stress the cables or other appliances before that place. So it will reduce surge, heavy surge, because if it short circuit and it has to blow out, it's going to create a kind of big surge. But if there's a breaker, when there's a short circuit by the surge protector, because it has performed its own function, protected the device, and it happened to now get damaged, then the breaker before it will trip off. Then when you see that, just replace the BMS. It doesn't mean that the inverter is bad. If the inverter is not affected, the SPD has done its work, then you replace it, and then you switch on. So it's always at that point. Then on the fire extinguisher, which is the green rail mounted, it's a very good device. It's a very good device, but if there's no rise in temperature within the component, there won't be fire at this. But anything can happen. It's just a kind of additional protection that we are talking about. If you don't connect SPD, it doesn't mean that your inverter will not work, but you are giving a kind of insurance. You are protecting your investment further. That's why you are putting it. So this fire extinguisher is also additional protection. In case something happens, maybe the breaker is now eating up there and is now burning and is already enclosed in the box. Instead of melting up the whole thing, burning the whole thing, fire extinguisher will just do his work, put it out. When you see that, then the problem will be corrected. Then the fire extinguisher will be replaced, because once it's activated and it has exhausted, then it has to be replaced. So you don't say it has worked and you leave it there. It's just like the SPD. Once it performs its duty, it's gone. Once it's bad, it's gone. So you remove it and replace it, and then correct other necessary part of the system. So they are good devices. Thank you very much.
Thank you, Engineer Kule, for that. Please, if you have questions, you can also raise up your hand. Would also give opportunities for you to ask. But while we are waiting for that we have other questions that have been typed. You have access to this on our YouTube, Genex Technology YouTube channel. When it's to be uploaded on the platform, so you can go there and be able to watch the video, watch the recording. So he said the second one said, which battery analyzer is good if I want to buy? So I'll leave that to Engineer Kule to answer.
Okay. Yeah. The very good battery analyzer is because I know that there are different brands, there are different models, and they have different specifications. But a very good one is the one that can analyze batteries across board. Whether wet cell, 2 volts battery, 12 volts battery, 6 volts, or any capacity, whether AGM or lithium-ion batteries. So you can get that type of analyzer having its maximum voltage about 100 volts. I'm sure you don't have a single cell that has 100 volts. So even all those batteries, you can't use it on all batteries at the time. You can only use it on one battery. You should be mindful of the maximum operating or rated voltage. So if the battery is going to be higher than the voltage, you cannot use it on it. You can get damage. But you can use it for each cell of a lithium-ion battery. You can use it for 12 volts. You can use it for even the whole battery together. Like maybe it's 48 volts. It's still lesser than 100. So, and then it will give you your results, give you the voltage, give you the internal resistance, and then test other parameters for you. So that's the type I know that is good. I know that there are some that are not rechargeable. They just operate from the battery themselves. And they have low voltage. Some are restricted to 12 volts. Those ones now, you cannot use them for anything. Some are just 12 volts. They can't even measure small battery lower than 12. Some are 6 volts. Some are between 6 and 12, like that. But the one that can measure from 0 to about 100, and then it's rechargeable, I cannot mention brands because they are out there. There are a lot of brands. So that's what you should look out for. They have internal rechargeable battery, and then they are digital. They have display. So that's it.
Thank you, Engineer Kule, for that. So if you have more questions, you can ask. Okay, so we have another question here. So the person said, say, how can we use multimeter? Say, how can multimeters be used for earthing and ground testing? So Engineer Kule will answer that for us.
Yeah, your multimeter can be used for that test if you load the ground. That is, you connect a load between the live and the earth. If the load is not powered at all, that means the earthing is weak, very poor. But if the load is powered, then you can now use your meter to measure the voltage. So when you use your meter to measure the voltage between neutral and earth at that time, if it's a very good sound earthing, the voltage between those two terminals will be low. Naturally, it will be around 0 volts, but you can get 1 volt up to about 5 volts. So that's the way to use it. You have to load the earthing. Since you are not using an instrument that will measure earth resistance, you are talking of your multimeter, and you are going to use the voltage part of it. The voltage between earth and neutral, they are very close. Once you are saying 200 volts between them, then you have poor earthing.
Thank you, Engineer K. Thank you, Engineer K, for that. So we'll go to the next. Say, kindly explain the concept of battery life cycle in relation to charging.
Well, battery life cycle will be affected negatively if you overcharge. Because in relation to charging, if you overcharge, you force charge the battery, then you will damage the battery, then it will affect its life cycle. You want to cut short its life. That's just this thing. Because as you do it, you will think you are charging it fast. It charges faster, then the life the battery is dying. If it is all those AGM, you will see them swelling up. They will be rising in temperature when you do that, and their life is reducing. So the life cycle eventually gets reduced. That's as regards charging. But if you don't charge as when you are supposed to charge, you have used battery now, you did not charge it. Maybe you now you are waiting. I don't want to burn fuel, or something happened. Is the battery is now under over discharge and is kept like that for some time. The battery will get damaged. The life cycle will also, if you use it, if that's the usage pattern, the battery life cycle will be reducing at a faster rate. I think that answers your question.
Thank you, Engineer Kule. So as regards battery life cycle, I'll just add a bit to it. So usually if you go through the data sheet of every battery, the manufacturer will state the number of cycles that battery is expected to run. So some might say 600 life cycles. Some might say, if you are talking about lithium batteries, they might be telling you 10,000, 6,000 life cycles. So each of those cycles actually talks about a charging and a discharge cycle. So it means that for every charge and discharge you do, so if a battery has 360 life cycles and you use it every day, you charge and you discharge, it means that you have reduced the life cycle of that battery by 1 day. So if you have used 5, you have reduced it like that. So the number of life cycle also is in reference to how you discharge and charge your batteries. So as you are doing that every day, the battery life is reducing. Okay, so presently we don't have other question. So if you have a question you want to ask audibly via audio, you can. We have one question. Say, can this slide and recording be shared with the participants here? Like I said earlier, we actually have the Genex Technologies YouTube channel. The videos will be uploaded, so you can go there, you watch the videos. Okay, I think Pamela
Yes,
also
hello,
has
hello.
a
Yeah,
question
I
for
can.
us.
Yes, I want to understand the concept of cycle properly. All right. Is it a cycle? Is it when you charge and discharge completely, or when even if it's not discharged completely and you recharge again? Is that a cycle? I want to really understand this concept. As in, at full charge, then maybe you go half, you use half, and possibly charge again. Or this full cycle is when you, as in at full charge, then you use completely and recharge again. Please, I need explanation, proper explanation on this. Thank you.
Okay. Enyake will answer that.
Okay, like he rightly mentioned, as additional information that time, that the cycle has to do with when you discharge and recharge. So it is expected that a full cycle is when you have drained the battery and then you charge it back. But then you and I know that when you likely discharge batteries, their life is longer than you expect. Some people are using batteries for 7 years when the stated life cycle is just about 3 years, because they put a lighter load on it. They don't discharge it fully. Some use battery for just 50% of the capacity and they charge it back. But one cycle in the real sense that, oh, you have discharged, you have charged back, is when you use the battery and you charge back. And then it's expected that a complete cycle is when you have drained the battery to its minimum and then charge it back. That's one cycle. But it's going to be the battery will last longer if you likely use it. It's not going to affect the lifespan quickly, because if you drain battery too deep, then the life may even be shorter. That's why you see that even lithium ion batteries, they leave something there. When it's communicating, you can see at least 5% left, not taking it to zero completely. So it's always like that. So that's it. I think that answers your question. And then you may want to add to it.
Okay. So I think Enyake has done justice to that question. So we'll move over to David. David, you can go ahead and ask your question.
Okay, good morning, sir. Good morning, sir. Good morning, everyone.
Morning.
Okay, so my question is as regards how I'm asking the engineer now, Mr. Engineer Kunle, that is it possible, or have you worked on a project where, or is it feasible to integrate all the EV batteries that are decommissioned into home backup integrating it with inverter systems? Because the battery usually have, like, I think the EV's battery usually have 10 to 20 years, and then they always have that the average is like roughly around 100 kilowatt hour. And even if they've done with their life cycle, they usually have enough energy. So do you think it's feasible with the technology that we have, or have you ever done a project like that, or do you think it's feasible for us to take that EV battery once they are old and integrate it as home storage battery to work with inverter, sir? Thank you.
Thank you. I understand what you mean. Probably they use them well and they are not damaged. It's not that they are damaged, because if they are damaged, they will be thrown away. So because they still have some energy in them that can be used, if you are a technical person and you want to integrate them probably for a personal use, no problem, if you understand the details about the battery. But for a business that you want to do with somebody who wants new batteries, it is not advisable. And then the integration, if one wants, the batteries are used already. So if you know how to integrate them, the terminal, I don't know whether they are like 48 volts, they can easily just be put into the system and start working with them with the inverter. What of the communication with the inverter? Is it established properly? So if all these communications are not there and the battery cannot be well managed, it is not advisable. Because this BMS stuff that we're talking about is the best that has happened to lithium-ion batteries, to make sure that they perform excellently and then they give rest of mind for human being. If not so, it can lead to fire, explosion, and all that. So if that part of it cannot be properly established, then it is not advisable to use the batteries for a system like that. I think that answers your question.
Thank you, sir.
You can go ahead. Basi, you can go ahead with your question.
Okay. My question is almost that of what the last caller just asked. I was just looking at a situation where we have most of this lithium-ion battery in the market, and most of them do not come with inverters or so. Is it safe, or is it also something that is practicable that you can have such like that and use it domestically for maybe a small load appliance that it can stand for? And then my fear is a lithium battery without communication. Does it mean that you cannot get any information from it? Does it mean that it is not actually safe for you to use it for any kind of installation without communication? Giving an example that we have most of this lithium-ion battery in the market like that, of different brands, just like that in the market, for someone that will just want to start maybe small to just use. Is it actually safe? Is this the investment wise also? Thank you.
Okay. Like I mentioned, lithium batteries are sensitive. They are intelligent. They did them to make people believe in them and to enjoy them. And that's why we see that the way they are coming in now, they are coming in more and they are taking over. Now, if anybody wants to use batteries, first of all, are you talking about new batteries? If there are new batteries, we have different brands, different models. It's not compulsory that they should have BMS ports that you interface cable or interface inverter to for communication. That there are some that design their batteries like that, and they don't have communication ports where you connect inverter to. Yet they have BMS in them. they still have battery management system, because it's not just one cell. Even if it's one cell, the battery management system is to make sure that the battery is not allowed to get overcharged, is not allowed to get over discharged, is not allowed to be overloaded, or all those, just to protect the cell so that it is always working properly. So if all this cannot be established in any battery that you want to use, don't bring the battery into your house, because you don't know what's inside. If you don't know if they have battery management and they are safe, then you don't need to use them, because explosion is not something anybody can want. But if you are sure, if they are new and you have gone through the specifications, you have seen everything, then you feel, oh, all these protections are available, then look at the inverter you want to use with it. Hope it's not the inverter that will stress the battery out and now make it to pose danger. Because if your inverter is not programmable and then it will always overcharge and over discharge, then you won't enjoy the battery. The battery will be disconnecting, protecting itself, connecting, and all that is a stress and can lead to anything on the battery and all the setup. So it's important to be cautious and then be knowledgeable enough to use these batteries. Thank you.
Thank you.
Thank you,
Yeah,
Engineer
okay.
K.
Thank you, Engineer K, for that. And I also add, for all lithium batteries, it is compulsory that a lithium battery is supposed to have communication, because lithium batteries have one of the shortfall of lithium technologies, that tendency to heat up and cause an explosion. So for that, because of that product, that line chain of products, discovered that a BMS is installed. The BMS automatically checks the temperature of the battery. All cells temperature are recorded by the BMS, and the BMS is able to regulate. If it senses any abnormal temperature rise that could lead to explosion, it shuts down the system to safe mode. So every lithium battery that you have communication or they don't have communication with, the BMS inside. So the fact that it's okay, you want to convert TV batteries into commercial installations, the place of BMS being part of the system must be established, and you must go through a proper Q&A testing to ensure that they are safe to be deployed to consumers. Those are things that has to be established. And like I said, a BMS communication, a BMS system must be installed for such battery cells for them to be very safe for people. Okay, so I think we have another question, which will be the last, that we'll consider for today, because we have run out of time. This one says, what's the major thing to be considered before buying an inverter? Let me repeat again. So this one said, what is the major things to consider before buying an inverter? So Engineer K will be handling that for us.
Okay, thank you. There's a lot to consider before buying an inverter. You first of all consider your load. What's the capacity of load you want to power? Then you now consider the type of load. Is it the type of load that demands heavy surge current, like heavy duty pump, that will first of all take like maybe 20 kilowatt when your inverter maybe times 3 or times 7, because surge current can be high depending on the appliance you are connecting to it. For most appliances, it's just about times 3. For heavy duty industrial, they are about times 7 or more. So you consider that. Then before you know the inverter you will buy, you consider the backup time, because is it just going to run on solar, or you want it to back up when solar is not available, or it's just grid and the battery. So you consider all that. So when you determine that, then you now know, okay, how long is it going to run on this load? Then that will tell you the size of your battery. So when you know the size of your battery, you will now still go back to your inverter. Can this inverter handle this battery? Because there could be conditions that you now make after you have sized based on your load. You may now need to increase the capacity of your inverter because of the battery that you want to charge. If the system requires a longer backup time that will make you pile up batteries, then you need a bigger energy to be able to store inside the battery. So you now need a bigger inverter to push the power into it. So you need like that. So now that's why I said there's a lot to consider. So you now look at your solar panels. Can this inverter be able to handle the number of panels that is required to charge the battery and power the load? If not, your inverter may grow bigger, you know. So that's the thing. But once you have considered everything properly and professionally, the system runs without any issue. Thank you.
Thank you, Engineer K. Thank you for that. Thank you, Engineer K. Thank you for that. We have one more. Okay. The pairs or product of lithium batteries of the same capacity in parallel. Can we connect different models of product batteries of the same, like collect part of this product and another 50 kilos of other products in parallel?
Hello. Thank you for that question. Please, I'll sound this as a warning. It is not advisable unless you are sure or given instruction by the manufacturer that, okay, this battery of this capacity can be connected to this, and they will give condition. What's the age? Maybe the same company that owns the brand names. If not, we can't bring Sharp and bring it and connect it to Sony and say because they are of the same capacity, maybe they are the same 15 kilowatt hour. The cells inside may be different. And then the BMS inside may be different. So it is not advisable. The only way you can do that when you have such is there won't be any BMS communication establishments. Then you just treat them like batteries, like individual batteries that are just connected to an inverter that is not communicating through BMS to any one of them. That way, if it's 48 volts, the other one is also 48 volts, they are connected to the same bus bar, they will take their power from there. In as much they are the same capacity, then when they are when power is pushed into them, they will take their power from there. When they are delivering power into the load, they also push to that bus bar. You can do that. You can connect many batteries to the bus bar like that. So that serves as a central point, but there won't be BMS communication. That is it. That way you can connect any brand, so far is, and then you must be sure that they have the same operating range of voltage, not one operating between 42 and 56 or even 55. And then you are connecting, because it's a 15 kilowatt hour, you are connecting it with the one that is operating between 45 and 58. So care is required here. One has to be very, very careful in doing all this, because it could lead to a damage of one of the batteries or lead to anything, because they are not the same. But if they are the same now, there is nothing to fear about. You know that they have the same specification, they handle the same voltage, they handle everything. So you know that you have to be very careful doing this. Thank you.
Thank you very much, Engineer K. Thank you for doing justice to that question. So we'll be rounding up the Q&A session. I want to use this opportunity to thank everybody for your time, for your immense contribution to this section. So on your slide, you see that we have our Genex Technology shop.genex technologies. Then you also have www.genex technologies. So those are our websites that you can use to source for our products. We sell solar panels, we sell inverters, we sell charge controllers, we sell batteries. Then also we have call numbers that you can call to ask any question, and also make requests for products. You can also make requests for your products on our website also. So thank you, everybody. Thanks for your time. And Yake, thank you for doing justice to this topic. I think everybody now they now have the capacity and right knowledge to be able to troubleshoot a solar system. Thank you, everybody. Thank you once again. Do have a wonderful day ahead.